Chapter 5, Lesson 6, Graphing Linear Inequalities. So now we're not just going to be looking at inequalities on a number line, but in a coordinate plane. And so we're going to be graphing those linear, not equations, but inequalities. So the first thing we're going to do when we are graphing is we are going to graph the boundary using slope-intercept form, and we're going to be using, we'll look at an example. If we see greater than or less than or equal to or greater than or equal to, it means a solid line. And if we see greater than, less than or greater than, it means a dotted line. All right, after we get that boundary created, we're going to use a test point, and we're usually going to use 0, 0 unless it happens to fall on our line, and then we can use 1, 1. But we're going to use a test point to determine which half of the plane, the coordinate plane, not the flying plane, to shade. And then we are going to shade. Alright, so let's look at two examples. Alright, the first one is 3x minus y is less than 2. So the first thing I'm going to do is get it into slope-intercept form. So I need to get rid of this 3x. Then I have negative y is less than negative 3x plus 2. Then I'm going to change their signs, or basically multiply by negative 1, which, don't forget, that means I need to switch the sign. So y equals 3x minus 2. Now, all I'm going to do is use slope-intercept forms. Remember, negative 2 is my y-intercept, so I go down to negative 2. My graph is going to be kind of a sketch. And my slope is 3, so I go up 3, 1, 2, 3, and over 1. And I put a dot. But before I just draw in that line, I need to think about, is it a dotted or solid line? What's my boundary? And I look at this sign right here, and I say, there's no equal to. So that means that it is a dotted line. Okay? If it had that equal to under it, it would be a solid line. And then I'm going to use what we call that test point, because basically I need to see, is it all of the points over on this side of the line that work? Or is it all the points over on this side of the line that work? So I'm going to use a test point, and I'm going to use the origin, because it's easy, 0, 0, and I'm going to see if that point works. If it works, then anything over here will work. If it doesn't work, then anything over here will work. And so I'm going to test it in there. I'm going to say, I'm going to go back up to my original equation, and I'm going to say 3 times 0 minus 0 is less than 2. Is that true? Well, 0 minus 0 is 0. Is 0 less than 2? Yes, it is. So that means that it includes my origin, so I'm going to shade everything over on this side of my line. And that's my answer, because it includes any x and y values that go right up to that line. It doesn't actually include the ones on the line, but it includes anything over on this side of the line. Let's do one more example. X plus 5y is less than or equal to 10. So again, slope-intercept form, minus x, 5y is less than or equal to negative x plus 10, divide by 5, divide by 5. Y is less than or equal to negative 1/5 x plus 2. Now I'm going to graph it. I'm going to go up to 2, and then it has a slope of negative 1/5. So I'm going to go up 1, and to the left, 2, 3, 4, 5, and there's my next point. And then I look at the sign, and I say it's less than or equal to. So it's a solid line. Oops, my line didn't quite get through there. And then I'm going to use a test point. Again, I'm always going to choose that origin if it's not on the line. Why? Because it's easy. Because I go up to my original equation and I say 0 plus 5 times 0 is less than or equal to 10. 0 plus 0 is 0. Is 0 less than or equal to 10? Yes. So test point works. I shade everything that is over on this side of my line. And that's my solution. Now, if If my origin was actually on my line, then I might want to choose like 1, 1 for my test point.